Okay. Um, these might use some vocabulary that for, half a second you say, huh? And then you get it. Let me just sketch out. I'm just going to sketch out a kind of generic, um, how should we say, a generic polygon. Like this one will be a pentagon, but just go with it here. I'm just going to show you the general idea no matter what you're dealing with, okay? When they talk about two consecutive radii, what they're saying is there's some point in the center, okay? And then you're connecting consecutive radii. Radii go from the center to the vertices, okay? So what they're asking for is what's this angle right here? Okay, what is one of these interior angles? Well, it depends on how many sides you've got. However many sides you've got, that's how many triangles you're going to end up with. So for this one, which happens to be a pentagon, you can see that you will divide that 360-degree rotation, because remember, um, let me get my pencil tool here. From here all the way around back to there is 360 degrees. So since it's a regular polygon, it's going to those five angles will split that 360 degrees equally. That would be for a pentagon. We're talking in 29, they're talking about an octagon. So we'll have to do something different, but I just want to get you the general sense of what you need to do all the time. You need to take 360 for and divide it by the number of sides, okay? And let's say n for the number of sides. And that's going to be the angle that you get for two consecutive radii, okay? So let's do that first for both of these. We can say A for 27 and A for 29. And let's see, for an octagon, so we will do then 360 divided by 8 for an octagon. And if you do the math there, you'll find 45 degrees. So that's A for that one. Okay, what about for a dodecagon? Well, you might not know what a dodecagon is, and that is a 12-sided polygon. Okay, so let's do that for 12. If we did it down here on the bottom again, we'd say 360. Now this time divided by 12. And you can see actually that, hopefully you can see this, that 36 and 12 perfectly divide into 3. So that works out to be 30. So then you get 30 degrees at each angle for a dodecagon. You're taking the 360 degrees and dividing it by the number of sides, because the number of sides is equal to the number of triangles that are formed by connecting that center to the vertices with radii. Okay, so we found the answer for A for both of those. Now, I'm going to do a little bit of erasing here. And I just want to show you something that's interesting. I think it's interesting. Okay, which is that, oops, sorry, hold on a second. Just want to add that back on. That's an A, answer A. Okay, now, to find B, which over here you can see is the radius and a side, which I'll draw in orange, okay? Here's a radius, and here's one of the sides. We're always going to get this certain angle in here. And how are we going to find out what that angle is? Well, this is what we're going to do. We're going to drop an apothem down here, okay? And what that's going to do is going to form a 90-degree angle, like that. And so when we found in the octagon that each angle, like the angle that you would get in here, well, actually, what I should say is not the angle that you get in here, right? And for an octagon, it was 45 for any one of those angles. That's going to get split in half by the apothem. So what we're now talking about is the angle that's in here, which is half of that, okay? Half of 45 is 22.5. So that angle up there will be 22.5 degrees. And since this one is 90 down here, whatever's left will be the angle that's formed by a radius and a side, okay? So we take whatever one of those central angles are by 2 consecutive radii, and again, in 27, for an octagon, we got 45 degrees up there. The apothem, that purple line that's in our drawing, splits that angle into 2. Remember, I didn't draw an octagon, I drew a pentagon just to show you. We're going to just generally imagine it happening for any particular type of polygon. So, okay, then if that angle is 45 between any 2 radii, then that's 22.5 for this blue angle up top. And then that leaves how much for here? Well, if we did the math subtracting, we would find it was 67.5 degrees. Okay, so then B, and actually let me just write A is 45. That's the original answer for A 45 degrees. Half of that is 22.5, and 90 minus that 22.5 is 67.5 degrees. Okay? And we'll do that same thing again over here for the dodecagon. I'll erase this and write 30 degrees again more neatly. Okay, and then for B, well, again, what you have to imagine, let's go back to our original kind of dummy drawing of some polygon. And let's look at this angle that's marked up top right here. Okay. This angle is whatever you get is one of these angles between 2 radii, and then for 29 it's a 30-degree angle here. Dropping this apothem down, we'll cut it in half, bisect it. So if it was 30, each one of those central angles was 30 for a dodecagon, then dropping that apothem and cutting it in half will make 15 degrees up there. And if that's 15 degrees, then what's left down here, out of the 90 that would be left over, after using 90 degrees as the right angle, we would find 75 degrees down there. So we have B, we have 75 degrees. And you can see the relationship, hopefully, is this. Let me get the numbers out of there, but check it out. Watch my laser pointer. Here it is, right? I'm going over to this. This one, we took 360 degrees, divided equally among the 8 angles, and got 45 degrees. Okay, that gives us this pink angle right here, if this was an octagon. Okay, now cutting that in half for 22.5 to find out what half of it is, and then taking that 22.5 away from 90 will tell you what this is. So this, half of this is 22.5, 90 minus 22.5 gives us this angle. Okay, and same thing here. If we took the 360 degrees and we divided it by the 12 sides, we'd find 30 degrees in each angle. Okay, and if each one of those angles going to the center, 2 consecutive radii, was 30, dropping an apothem would cut it to 15, and then you would take that 15 away from 90 because these 2 angles would add up to 90. So if this one was 15, then what remains is 90 minus 15, or 75 for this one. Okay? And so again, my drawing was not for either one of these particular shapes, but just to show generally parts of the polygon.